In our last video, we took a look at the graph of a polynomial function based on what we know about its end behavior, its leading coefficient, its degree, and then the zeros. Today, we're going to kind of look at it backwards. I'm going to tell you the zeros, and then we're going to figure out what the function might be. So right now, we're going to assume that our end behavior is positive as we head to the right. All we know for sure is that the zeros of the function are 4 with a multiplicity of 3, -4, and then a half with a multiplicity of 2. So let's describe the end behavior of the function, let's graph the function, and then we'll write the function. So I'm going to begin by listing the zeros. So as I list the zeros, x is equal to 4, x is equal to 4, x is equal to 4, a multiplicity of 3. Now, we didn't talk last time about what multiplicity means in terms of when multiplicity is odd. In fact, I'm going to erase this. I'm going to write odd multiplicity. If you have odd multiplicity, then your function will actually cross through the x-axis. Okay, so x equals 4, x equals 4, x equals 4, x equals 3. That's also technically an odd multiplicity because it only shows up once, 1 being an odd number. Oh, and then x equals -4. No, I'm sorry, I'm reading this wrong. X equals -4. That's a multiplicity of 1, which is odd, which means it's going to cross through. We'll cross through here. And then x is equal to a half with a multiplicity of 2. And this is even multiplicity, which means that we're going to bounce at 1/2. All right, so we have 1, 2, 3, 4, 5, 6 zeros. What this means is that our function will look like f of x is equal to x to the 6th power, and then so on and so forth. Well, what we know about an even degree is that it has the same end behavior. So what is the limit of the function as x approaches -infinity? What is the limit of the function as x approaches +infinity? Well, like I said, we're going to assume that the leading coefficient is positive, so therefore I know that as it heads toward far right, the function's heading toward +infinity, and then x to the 6th power. Again, I just know for sure that this is going to have the same end behavior because 6 is an even number. All right, back to business here. So we've talked about the end behavior. What else did we want? We wanted a rough sketch. We can do that next. I know that I'm going to cross through at 4. I'm going to come through and cross through. That's ugly. Oops. I'll cross through at 4. I'm going to cross through at -4. Here's the -4. This is +4. And I'm going to have a bounce at a half. So this is going to be a bounce point. I'm going to cross through here, and I'm going to bounce there. Because I have the same end behavior, I'm willing to bet that as I head towards the far left, I can go ahead and draw that arrow up. I just need to make sure that I have 5 turning points. Oh yeah, don't forget about the turning points. I have 5 turning points because the number of turning points is 1 less than the degree. 5 turning points. Let's see if we can make that happen. Okay, I'm going to come down, I'm going to bounce. I need to turn and come back up. Now, technically, that's only 1, 2, 3 turning points. So I said this is going to be a rough, sketchy sketch, and sure enough, that's what we're going to draw. I'm going to erase some of this, and we're just going to kind of add in a couple more turns. Check that out. How many turns do I have now? 1, 2, 3, 4, 5. Yep. So what happened here, and here, and here, and here's my turns, and here I have 5 turns. And I just made these 3 random turns kind of, you know, like down here. I just drew those in. I don't really know if those happen, but this is a rough sketch, and if you were in a multiple choice setting, you would know to look for something that had these random turns somewhere. These come from complex zeros, and we don't really know where they are right now until we, I don't know, look at more of a graph or something. Okay, so rough sketch, good enough. We're almost done. This is our rough sketch. The only other thing we need now is the graph. No, I'm sorry. The only thing we need is the function. So let's write our function. So to come up with the function, I'm going to think of each of these zeros as a factor. Each zero as a factor. So I have x minus 4 times x minus 4 times x minus 4 times x plus 4 times x minus a half times x minus a half. So there's how I could write the exact function. Again, these x minus 4s turned into the zeros x plus 4. If you think about setting that equal to 0, this is where I got x plus 4. Think about if that had been set equal to 0. Now over here, I want you to watch this. This is x minus a half equals 0. Or I could also write this as 2x minus 1 is equal to 0. So another way I could write this factor would be 2x minus 1, and this one as 2x minus 1. So when it's all said and done, it kind of looks like I'm going to have a leading coefficient of a 4, to tell you the truth. Now, how tedious and annoying and error-prone would it be to actually write this function, you know, to actually multiply all of this out? Ooh, yuck. No thanks. So for our intents and purposes, we can leave it just like this. That's a good enough function for us today. All right. Do you need to rewind? Did I lose you? Are you good to go?